Hello, Mr. Gazda here, homework 580. Here we go. The generalized cross-section below shows the sedimentary rock layers at Niagara Falls in western New York State. So, cross-section means like you cut down through the rock. Look at the sides of the rock here. And let's see some of the questions, what are the choices are. Which rock layer appears to be most resistant to weathering and erosion? Keyword being most. Most resistant means it resists weathering and erosion the most, and therefore it's been weathered and eroded the least. And the key thing to waterfalls you have to realize is that this right here, the top layer, must be most resistant. That's why you have a waterfall that forms. So that's a key part to it. So the answer should be this Lockport Dolostone. Choice 1 is the correct answer for the first one. 25. Excuse me. 4 quartz samples of equal size and shape were placed in a stream. Which of the 4 quartz samples below has most likely been transported farthest by the stream? Okay. So they started out same size, same shape. Key thing should be the answer is 4. This has been transported farthest. How can you tell it's most rounded? Most rounded, as you know from the rock abrasion lab or the rock shaking lab, as it rubs up against and into other rocks, it will get more rounded. Edges will chip off. Answer to 25 is 4. 26, similar type question. 4 pieces of same rock types are shown below. These pieces were transported exactly 4.2 miles by a stream. The rocks were of identical size and shape when they first entered the stream. Which of the pieces appears to be least resistant to weathering? Again, resists weathering the least. Okay, resisted the least, therefore it's been weathered the most. So the one that's been weathered the most is the least resistant. Also, this choice right here. Okay, because it's rounder, the most rounded of those. Okay, 27. Which will increase the rate of chemical weathering of limestone? Increase the rate or speed or how fast it happens. Chemical weathering limestone. So some key things here is reference table. If you were to look up, something about chemical weathering, something about limestone. And I don't expect you to really know it. You can look up here. What do you know about limestone? Use all your resources. Limestone here is composed of calcite. Hopefully you can recognize, or if you need to go and look, calcite bubbles with acid. That's the mineral that reacts with acid. So things that can increase the rate of chemical weathering of limestone. 1, water in contact with the limestone becoming less acidic. No, that's not true. It would become more acidic to increase the rate. Decrease in air temperature, increase in felsic nature of limestone. That's kind of just one of those throwaway questions because limestone is not felsic. That's not a characteristic. That's an igneous rock, felsic or mafic, so it's definitely not that. The answer is increase the air temperature. And that's something you need to know is that the hotter temperatures, when it's warmer, chemical reactions occur faster. Okay, know that. So the answer should be 4 to this one. Colder temperatures, chemical reactions slow down. Okay, on the back we have A and B. These sediments A and B. Notice here, all different sizes. Here they're all similar in size. Which is sorted? Answer, sorted is B. B kind of means all of similar size, as if you went through and sorted them based on size. This we say unsorted when the sizes are mixed together. And this, which column will have the lowest permeability? And here I give you the definitions. Permeability, how easily water flows through. So the lowest permeability, A or B, means the water will flow through the slowest, most difficultly, and the answer is A, because getting through here is a lot of rocks in the way. Here, there's a lot less, so lower permeability would be A. Higher would be B. Always got to ask, make sure you know what they're asking for here, higher or lower. You really got to kind of slow down your brain to think about it. Which will have the highest water retention? And that is, water retention is water that stays on the sediment after it has drained. So some will always remain in there, and it will cling to the surfaces here, and it will cling, water will kind of cling to all the surfaces, like in this little area here. And then you'll even have some water kind of cling like this, and it kind of clings like this. It'll cling there, it'll cling there, right? So you can't get all the water you poured in out. Some will stay in there, kind of cling right there, there. Is what water would do. So the highest water retention would be A, okay, because these spaces are much smaller, much more surface area. You'll have more water retention in A than you will in B. 4, which would have more infiltration during a heavy rainstorm? Infiltration, you have to know what that is. Rain hits the ground, it can do one of two things: infiltrate, which basically soak into the ground, soak into soil, or it can run off, which stays on the surface and either form a puddle or flow downhill. So more infiltration during a heavy rainstorm. We want water with high permeability, easy to flow into. Therefore, B. More infiltration, more water's going to go in here than here. And 5, which has higher porosity? Porosity, you know these terms. Know these terms here. And infiltration. Porosity, how much water it can store in its pore space. So the answer to this one is B. Higher porosity is B. This, the smaller rocks kind of fill in there. Less open space, more open space. Higher porosity is B. So that's homework 580. Thanks for watching. For myself, Mr. Gazda, all the folks at Gazdonian Productions, thanks for watching.